Good afternoon. Today is Saturday, December 3rd, 2022. My name is Wahid Lutfi. Let me share my screen to show you what I have for you today. Thanks for joining us. So what you see on the screen is MyWebUniversity free education videos. And the series of Python programming or Python sessions that I have provided you so far. There's a number of them. We were discussing the Python data structure on this video, and we covered Python tuples on these two videos. But I'm going to cover Python list because Python tuple was the first one that we covered. Python list is the second one we're going to cover. So let's just make sure that I'm sharing my screen and also showing you the slide view of this one. So let's go with this one. As you can see here, I've already prepared the lecture for you, and then we're going to go quickly through the lecture, and then we're going to do a session for you to actually do the Python lab activity so you can exercise it as your time allows. So let's get started. So Python tuple data structure, we discussed that one last time. List data structure, set data structure, string data structure, class and object, and data dictionary in the previous session, as I mentioned. And Python tuple, this video, we're giving you examples of these Python. The actual videos that are maybe 39 minutes or something. So I made some shorts on some of these ones so people could get introduced to these nice videos that are available for you on YouTube for free, that you could learn from it, whether you want to learn it from for school or education purpose, or learning just in general to help you at your job. So Python list data structure we're going to cover today, which is the topic of today, Python list data structure. And then what are some of the features of Python list data structure? First of all, list is immutable, meaning that you can modify an element of a list. Unlike tuple, which was read-only or immutable elements, list is a mutable sequence of elements. And then we are going to also talk about list slicing. So you can do some sort of like these lines that I'm doing on line 6 here. But I'm going to show you those ones in examples here. And then list conversion between a tuple, set, and strings. So we can do conversion between 2 or 3 different data structure when we are using it. Whether you convert it from tuple to list, or list to tuple, or to set, you have option, or to string, or string to list, you have option on those ones. Some of the other topics when I'm covering, I'm going to go details on each one of them, because each of these object or class, they have a lot of methods. The class has a lot of methods, and then for example, for list has a lot more methods than a tuple has. And then the options that are there, and tuples are small in size compared to list, but and tuples are also faster and then list. So you have option of list comprehension as well. We're talking about here a number of things. So the other topic that I didn't put it here, list comprehension, I'm going to give examples here. But the list methods like sort, how you sort it, and then also sort versus reverse order, and that's 2 different topic that you're mentioning. Reverse order is not sorting it, it is just reversing the order. On one of the previous video that I post, I believe it was on a short, I mistyped the word sort, replaced the sort for reverse, and someone nicely put a comment saying that this is reverse order, not sort, and I say thank you. That was the intention. My intention was to write reverse and unfortunately, mistakenly, I typed in sort. So when you see some kind of like typos or something, please just put nicely some comments and I'll correct it. So it is available for other students and other people's, and they know that, okay, that was a typo on my behalf. I appreciate it. So at the same time, I'm going to talk about list extended, append, and insert method. There are different methods, and then they have different purposes that you have to understand them. And there's an index method and other ones. I have not mentioned it. There's a lot of method, so that's why I put dir of list and type list and help. You can always get the details on each one of them if you're looking for a list. Directories, and then or you can get help on a list a method like help list dot insert, for example. And then we are also using list classes with object-oriented method style. So list element dot and dot member functions. You could do that one, or member methods. So you could do that one. And then this one would be the right side. This picture is actually on collab.research.google.com secure page, which is a notebook for Jupyter Notebook of Google that kind of gave you a sandbox so you can practice it. And I'm using that one. It is very helpful for teaching, for learning, for practicing online. So all you need is a browser and internet access. So you're welcome to use that one, which is https://collab.research.google.com, and it is free of use, and it's good for learning purpose for students, especially that you can do some projects online or collaborate with your friends and co-workers. So it is a good Google secure page that you can use notebook, Jupyter Notebook on Google site. And then let's get to the next one, which is the actual Collab website. So I'm logged on https://collab.google.com, and I already wrote what I had on the screen here to show you some of the examples. With that, we're going to start with this example, but at the same time, I have it on a notepad here. So I'm going to discuss these ones. List is immutable, and we're going to show that it is mutable, that you can change element, list slicing, and list conversion, and so on. So let's get first to show you. I'm going to delete all of these and then start off with printing this at this time. So on line 1, I don't have anything to say, but I'm going to say print L1. So if I want to get the list of print L1, it is there as 0, 5, 10, 15. And when I say the topic here that it is list is mutable sequence, that means that you can modify an element of the list. So how I do that one? I just say basically L1 sub 0. If I want to just change that one to 100, let's say, then print that one, print L1. And then you can see that this is basically now the elements is changed to 100, and that's how it's immutable. And if I want to change the first element, second element, in this case 5 to 100, then you see that elements. So at the same time, while I'm changing the element, I'm going to show you that these are indices. So the first one is L1 sub 0, L1 sub 1, L1 sub 2, and L1 sub 3. So I could just say L1 sub 3, which would be the last one. And then if you do L1 sub 4, this is going to be out of range. Watch this one, because there's only 4 elements. You cannot get this one. So you have to do -1 here. Whatever is the length of it, it is going to just give you the last element. So at this time, if I just changed -1 here, that means I changed 15 to 100. And then you can also print a list. So we did modify it. you can also use a list with for statement. So you could say for item or L in L1, and that would be like L for item, would be print L. So this one, I have to move it inside here for a for statement in order to have the right syntax, because it's 4 columns after the colon separator. This is you're going to a subsection within the for loop, so you're going to like begin and end. So this time we printed out L1 L054, and if I want to just print out by slicing, what I mean is like if I want to print out 0 to 2 element, the first 2 element, 1 and 2, and then this is 0 and this is 1. If I want to include the 10, then I'm going to go to 3. This is also slicing there. So the earlier example that I had, and it is on the lecture also, I'm doing a different slicing. I'm giving you now different syntax and different way of doing it. Here, if I want to just do print a statement, for example, to print everything, I can also do slicing like this also. Whether you do print L or print L and everything, that would still print everything here. So if you want to just do what I did here, 0 to 3, that way 15 is eliminated in both situation. You can see that that is the case. 0 to 3, you go there. And if you want to go in reverse order, for example, just reverse order, not sorting it yet. So let's just do in reverse order, -1. -1, the first one is going to print it in reverse order, 15, 10, 5, 0. But notice that I'm covering all of it. So I could just say colon here, that would be printing everything 0 through this. Or I could just say, just do this. I don't have to even include the order, because of this one means everything. And so that syntax and the other syntax is the same. Another thing that you could do is for the list, this is an order that you change it. But if I want to just get rid of the reverse order versus the sorting, so I could just say L1 dot sort, and then I could just do this. This is doing an in place sort. So at this time, if I just say print here, notice if you do a print here, it's going to say none, meaning that it is, this one is an end place. This one meaning that you're just end place, you're sorting the element L1. So now if I just say print L1, then it's going to just say that, okay, after I sort it, now the element is in sorting order. But obviously, the other one was in reverse order. So if I just change this data to have some different elements. So let's say you say create a list, and then I'm just going to say 0, 100, and 50, and 21. So those ones are different elements. And then now notice that I created those one, but here, since I sorted it after the sort, it is printing it. So this one is saying none, because I know that if you're just trying to print the sorted element like this, it's going to say, well, you're doing an in place. You actually want to just print it and sort it. So, and instead of doing this, you could just say, assign this one L1 here to, let me just go here. And then I'm going to say L1 underscore sorted is equal. And then here I'm going to say L1 underscore sorted. So I could print that element. And then this time, because I did it here, look at this one, it says it is in place. But this one is not just assigning it to this, right? So I need to just say L1 dot sorted, and then at this time, if I just do L1 dot sorted, let me just think about this one. So it is printing this one because it's in place, So in order for me to actually print the L1, then this would be just the actually sorted number, because we sorted that one. So 0, 21, 50, and 100. And now it is in sorting order. So this one versus the other one, notice that this one is L1.sorted. We assign it to a variable, and then that variable, which is also a list. And if I print the type of both of them, print L1 underscore sorted, and then print L1, the type of them. And so let's get the type of them. Then notice that the type of both of them are going to say list, because we are doing a list to list data structure. So one is that says class list, and the previous one, because we did a L1 underscore sorted, it says none type. So that is not a list actually, because you're just assigning this one to a list of non-sorted, like we were printing the list L1 that would also print it as this. And instead of this, if I just put this statement here, watch this one. If I just do this one, it's gonna say none when you print that one, because that is in place. We're changing the L1. So notice this one says none here for line 7. So let's just remove all of this line here to get it clean here. We're going to talk about some other thing here. I'm not going to talk about slicing. Actually, on slicing, let's talk about slicing here. I'm going to print 0 to last element. So you can print 0 to last element like this too. And then if you just want to say print everything, that was everything but last element, and this one is everything, 0 to last element. And you can also say, for example, length of L1, this one would be this, but then you have to do a -1, because otherwise you get out of range. Length is the Python function, so 0, 150, and then when you do -1, it is good, it is 21. So length of that one should give me just all the elements. And as you can see, it is this. So if I just say print L1, L1 dot underscore underscore length, so notice that some of these methods are going to show up here. So you could do this one as a function and see what it prints. It should print the number 4, because there's 0, 1, 2, 3. 3 as there's 4 elements altogether. So the start index of sub-0 is this, index of sub-4, which is 3, is 21. So if I want to print the last element, I'm going to say L1 sub-4, sub-3. Sub-3 would, because it's the start from 0 up to 3. But if I do a 4, this is going to go out of range. And this one is going to give you error, and it says list index out of range. So you don't want to do that one. If you do that one, you could just say 4 minus 1 or something. It doesn't matter. 4 minus 1, it's like, or 3 actually. You don't have to give, you know, values there, but you could just either put a value, or you say length of this one of L1, like we did here. You could also do a length like this or length like this. This is also understandable. And so when you do this, let's see. Okay, so index out of range in this one, because length is 4, you cannot get length of sub-4. So in this case, I have to do a subtraction here, and then that would just still okay in 21. So look, notice the difference here. This one is L1 dot underscore length, and it is completely showing you 4. But here, when you do the length of L1, it's going to return 4. You cannot do a sub of that one, and then you have to do a -1 in it to get 3. So L1 of sub 3 is going to be there. Okay. And then if I want to just use this as one, I'm gonna say print, for example, similar to that one. I say L1, and then I could say sub this, and then print this one. Notice this one also going to return 4, so this one should also give out of range. So when you get this one out of range here, index out of range, then you could say, okay, link to -1, because that one is the last element. -1 is going to give you 21. So you get on both situation 21 as we expected. And then let's just do the same thing with reverse order, printing less than reverse order. So L1 dot L1, and then you want to do the whole less than reverse order. This is how simple Pythonic way to print a less than reverse order. That is not the same as the sorted order. This is just going from the last one, printing the last one to the end there. You can also accomplish the same thing for, let's say, item in L1. You could just say print item. Now I'm just getting it 0, 150, and 21 here. But if I want to just do this one in reverse order, then I have to put the list here, this syntax of -1, go from the last one first and then print it. Now 100 is 21 is the first one, 50 next one, 100 in reverse order. So you could do that one similarly, similar to this statement. If I put a print statement, this is a shorter form, Pythonic way, and this for item is also has the Pythonic way here, but you're writing more code. The simpler you write the code is better. So you can see that is there. And now we're going to talk about this one versus actually sorting. So now we say, let's just talk about sort versus reverse order. So sort versus reverse order, sort and reverse, for example, and reverse, and then sort versus order. We're going to discuss both of them. So if I just do this, and I want to just say L2 is equal, rather than say L2 underscore sort, I want to just have shorter form, L2, and then say L1 dot sort. So now this one will just say print L2. Now this one will just say that the list is sorted. Notice that the list is sorted, but L2 is none, because I did not just L1 dot sorted. We assign it back to L2, and L2 did not get changed. L2 got changed to this. So printing L1 is in sorting order. That's the difference between in place and versus the other one. So this is a good example of showing you that 0, 21, 50, 100 is in sorted, because we're doing L1 dot sort, meaning that we're doing in place. So in order to accomplish assigning it to a L3, for example, I could say L3 and then is equal, and then I say is equal. Now I have to use the Python sorted and then L1. So now this time if I say print L3, this one is also similar to L1 in place sort. And notice that it is exactly the same, these two. So notice the difference between them. Obviously, there was a difference between the reverse order versus sort. Reverse order just puts the last element first, and then the previous element before that one for second, and so on. And then sort, it is going to just check the numbers alphabetically or versus some other things, and then sort them. So with that in mind, now you know the reverse order. I'm going to remove these ones, and I'm going to create a new list. So the new list, I'm going to be having like called cars. let's say just call it cars is equal. We're gonna say BMW, let's say BMW, and then we say Ford, and one more car, let's say call it Toyota. So these three elements are there. Now, because I said cars is a list, obviously if I say type of print type of this one, is going to say that this is a list. So I'm going to delete these ones here. I'm going to just print that one, so you get a list of a type of cars. I need an object there. So print type of it says a list. Now, if I say print dir of cars, that's also gonna say that these ones have these methods. Similar method that were on the other objects, you have all of them are here. And if I just want to say for C and cars, print, I want to say print C, but I want to say every time it prints it, I want to see the value in column wise. And then you can see that it is printing these ones. So let me just take these methods out. And actually, I don't need these two right here. And then now I'm just printing these. So you can see that it is going to print the cars. So if I say here, say print cars, you could do that one as well. And then you see the list is like that within the list one. But when we are doing it, the one string, you're actually getting a different thing. Rather than a list, you could say print type of C. Now we're getting basically that class string, because these are all strings. So if I just have some numbers here, like 5, and then the last one, and then another number of 5.5. So let's see if I just make the list shorter. I don't want to have too many objects. It's easier to understand. This is a 5, and then let's just make this one a Boolean variable, false. So inside the list, you can have different data type. You can even have list of lists. So you could just do that one. So here I'm doing one list, but notice that BMW is a string, the false is a Boolean, and then the 5 is an integer, and then the 5.5 is float. Now I can just create another list, say numbers, and then is equal, and then just say list of 5.5 and 10.5. So this one, I'm going to just, instead of these two numbers, I'm going to just include num. Notice I have now two lists. One is num, and then I'm assigning num to be a list of nested list in the cars. So now I'm still doing that one. If I just say print type of num, this is the same as print num. It's going to just say that is a list, and then the type is also a list. And then here we're doing that information with BMW and false and everything else. So let's see what other things that I could cover, because some of the other topics I wanted to cover here is I'm running a little bit out of time. So I'm going to create a list of comprehension. So a list L1 is equal, you could say L for, we're going to write a list here, L for L and range of, let's say, 5, 30, 5. So we start with 5 and increment by 5 up to 30. And then we say print type of L1, and then increment, print L1 itself. So notice that when I do this one, I have these numbers, and then these numbers are in different range. So now I'm going to append some numbers or insert at the very beginning. So let's just make this number only a small number like 15. We have only 2 elements here, 5 and 10, because we are incrementing it by 5 here, and then start with 5. So the next element is 15 is not going to be in the list. So here I'm going to just add to on this list. I'm going to say L2 is equal. Let's just create another element, say 2 and 20 and then 1. So I'm just creating an index that is not sorted, so I can show you a sort function here. Now I'm going to say L1, L3 is equal. Let's just extend the L3 as L1 dot insert L2. So we're doing print L3. So now we're just using the insert method, but insert has 2 things. So I'm going to say inserted in the very beginning. 0 is meaning that inserted on the index list. And then L3 is now, again, we're doing an in place, so I need to print L1. L1 is the one that we modified. So now L1 has 2 lists, a nested list, the first one and then that one. If I want to just append it, this is different than insert. So let's just do print L1 dot append, and then since L1 is there, I'm going to do append, and then at this time I'm going to move that line above the fourth line. So print L1 dot append, we're going to do append 2 to it. So let's see if we get this one, and this one is in place again. It's going to do that one, and so append is there. And this one I'm going to assign it to L4, and then this one when you do append, print L4, and then again print L1. So let's see, and the values for line 4 we have this one. For line 6 we have none because we're appending it in place, and for line 7 we get this last one appended, meaning that instead of inserting it right here on the first one, so I'm going to print get this one is, I'm not gonna assign it to a L4 element. I could just also do a del L4. Del an object, you could delete an object there. You don't need to do it. But notice L4 here is going to give an error, none, because it's deleted. So instead of doing all those these 2 lines, we're going to just get rid of this one. So we don't create an object L4, and then we just do this work. And that would be the same as showing you the example of insert versus append. Notice insert is inserting at the first element, and it's going to insert it as a list here. So one nested list inside another list. The append is going to, as the word says, append at the end of it. So it is going to do it. Insert does not have to be inserted on the first one. You can do, the 0 first one, you can do it on the second one. So notice 5 is there, then you insert it. You can do it at whatever index you want to do. So 2 is there. You can insert it after 10. And if so on. You can always do that one. But append is always, you don't have any option to do it there. I'm going to just cover one more thing here using the extend comparison with extend. So L1 dot extend meaning that extend the list. So if I want to say extend it with L2, you could just do this one and then say print L1. Now notice that the difference between the 3 of them. So the insert, so extend. Let me just see what I missed it. Oh yeah, extend. This is not a list, it's an element. So you have to say extend is a function that takes an argument as a list. So now it is extending. Notice the difference here. So since L1 was modified a lot here, I'm going to move this line here out, and I'm gonna put it right after this one. Because when I extend it, notice the difference. Here, you see that the list of list and list there, that was extended, but at this time, I just want to show you the difference between this and the extend. And so the first one, it is printing L1.extend is this line that I highlighted for line 3. So that it prints 5, 10, and then extend it for the next list, and then does that one. So the L1.extend, let me just check one thing here to make sure that I'm covering the extend here properly. Append, extend, and insert. Extend is doing 5 this and there. Let's just declare something easier. It is too much with those numbers, I could see it. So let's call it sport is equal. We're gonna just say soccer and then football, 2 of them, foot and ball. And we're gonna just say sport dot extend, and we're gonna just add to it. So we just add another sport for this one and say running. So running, and then print the sport. And then notice this one is coming as a string because each one of those words or individual characters, it's inserting it. We're not extending it in like a list there. And if I just change this one to do this, and then comment this line out, sorry, comment this line out, and I'm going to do append. Append. This one will just add a running at the end of the list. This would be a list. And the other one, individual characters are showing there because running was just doing an extension with this one. But extension running was not a list itself. Running was kind of a string. That's why that one was there. In order to create a list that is empty, you could say S is equal empty, like this. And then that would be there, or you could say list of empty elements. So this is another thing you could do. But if I want to just add one element to it, and then I say running, and then I put this one in code, and then just do this one. Now all I have to do is this one, do a S here, and then take this common out and to compare it. And notice that this one also shows running, and running was added to the second time. So this one, it did an in place and then running. If I change this one to like say tennis, let's say, or let's say basketball. So let's just do those. You can see that running was added as a list rather than when we did it as a string. This was not a list. So here, if you just want to add something, say string one is, and you say Wahid. Notice this Wahid, when you extended this one, here I'm going to just say sport.extend, and then say S1. Now this time, if I say print print sport, this S1 is because it's a string, then it's going to just create this one as individual kind of string characters and there. So to prove that one, you could say for item in item in sport, sorry, in a sport, and then we're going to say print type of item. And then you could see that the type of item is basically on each of those elements or strings. You could see that they are string. So that's the difference. But here, if I just want to do after this sport, before this one, when I did the basketball, and I say here for item and sports, we have a sport, not a sports, print item, print type of item. This one will say a string, I'm sorry, list, because that's each one of those ones are list element. Actually, there are string inside the list. The values are string because this is still in quotes. So if I change these ones, even though I call it the sports, if I say 5.5 and then 5, and then say this one is add another one, say true. This one is saying football is a string, 5 is an integer, and true is that. So the data type matters right here because there. And then you could also check for existence of a word in there. So let's do one more thing. You could say if the word football and sport, and then say print, please watch World Cup. World Cup. So you could say that the statement, if football is there and it says please watch World Cup. Please watch World Cup 2022 in Qatar. Today, Argentina played against Australia. Argentina won 2-1, so they're facing Netherlands. Netherlands also win against United States 3-1. So Netherlands and Argentina is already in the quarterfinal, which is round of 8. But let's see what other teams are qualifying. Please watch it and enjoy it. And I hope you enjoyed this video. Thanks for watching. God bless you all. Have a nice one. Take care. Bye-bye.